Okay, we're going to take a look at exponential graphs now. Exponential graphs, we've done exponential functions. So they take this form, y is equal to bx, where b is our base. And we're going to take a look at what the graph does, and when we change b, what happens to the graph. So if I just play the slider, it does all kinds of crazy things. Goes to -10, which completely goes off the fray. But then when it gets to be, I'm just going to slow this down. When it gets to be, does at 1, when b is 1, when the base is 1, it's a flat line. When b is greater than 1, it does this. And so that b sort of affects the steepness of the graph. Now you'll notice that when b is, there's 1, greater than 1, it shows this kind of graph. This is called a growth curve. So going from left to right, this graph is increasing at an exponential rate, which happens quite frequently when you're talking about populations of species and microorganisms and so on. Their population increases exponentially and so on. So that's what happens when b is greater than 1. Now look what happens when b is less than 1. The graph changes. So going left to right, now the graph decreases. This is called a decay curve. So decay, going down, growth. A growth curve, a decay curve. And all it is the base is changing. And the base is now, to have a decay curve, the base is less than 1. B is less than 1. And we want to go into negatives. So b less than 1, but greater than 0. Decay curve. B greater than 1. It just keeps getting steeper and steeper and steeper. Okay? So those are the features of an exponential graph. And the other feature is, watch the y-intercept. The y-intercept, no matter what kind of graph that you have and how b changes, is always at, the y-intercept is always at 1, 0, 1. Now, when you get into your worksheet, it'll become quite obvious why that is the case. If you think about it, if x is 0, y would be 1, and you can think about that. Now, the other very important feature of an exponential graph is what's happening to the left of the graph if you're doing a growth curve. And this thing, as you can see, is approaching the x-axis. And it's getting close and close and close to the x-axis. What we need to find out is, will it ever touch the x-axis? And now the software will only go to 3 decimal places. So although this is getting closer and closer to x, the fact of the matter is, this graph, an exponential graph, actually will never touch this x-axis. It will never get to a place where y is 0. It'll just keep getting smaller and smaller and smaller. And when you bring up your worksheet and you do your table of values, you will see that that is going to be the case. No matter how small x gets or how far along the x-axis you go, y is going to get smaller but never get to be 0. Y will never be 0. So that fact that the graph will approach the x-axis but never actually touch it is called an asymptote. And an asymptote is a very important feature of a graph. And it is a value that a graph approaches but never gets to. So in this case, you can say that the asymptote is at the x-axis, or when y is equal to 0. In other words, the graph will never actually get to y is equal to 0. That's what an asymptote is. So the features, the y-intercept, what the graph does, what b does, and an asymptote.